Hi everyone, in this small video tutorial we will talk about how to simulate a projectile motion using an Excel sheet. So let's assume that we are throwing a ball in the air at the velocity of 100 meter per second, and the angle of the throw is suppose 60 degrees, and we have a gravitational force G which will act towards the ground, so it will try to bring the ball towards the ground, and the acceleration from the gravity is 9.8 uh, meter per second square, so second not second. So now from here we want to calculate the trajectory of the ball in the air. So let's first assume, so we can use a numerical approach. So let's define the time. So time will be equal to 0 in the beginning, and then let's say we have a dt. So dt is the small time step at which we will calculate the point or the position of the ball. So the smaller the dt, the more accurate our calculation will be, but this is just example, so I'll just take a 0.1 second here, right? So now as you can see, the time with the time, so each time the time will increase by 0.1 second or dt, and I'm putting a dollar sign here so that it does not change the position of dt. So you can see that, so the time increases from with the interval of 0.1 second. Now let's take the velocity. So velocity in x direction. So now velocity in x direction will be equal to velocity multiplied by sine of the angle at which we have thrown the ball. So here because this is Excel, so we have to convert the angle into radians first. So I'll say radians, and then I'll click on 60 degree, and I put a dollar sign here and dollar sign here. So it says that the velocity in x direction should be 86.60 meter per second, and the velocity in y direction should be equal to again velocity into the cos of radians angle and then again a dollar sign here. So that will be the velocity in the y direction. So now we can check that have we done the calculation right or not. So let's take this cell and I square the velocity in the x direction and then add it to the square of velocity in the y direction, and you can see that the answer is 100,000, and if it takes square root of this number, then that will be equal to 100, which is actually the velocity. So that means we have done it correctly, because sine square plus cos square is equal to 1. So here that's why the velocity in x direction and y direction, the square of the sum of them should be also 100. So now please enter that. So now as we know that in x direction there is no force which is acting, because it's a horizontal direction, we are ignoring the resistance due to the air. But in y direction we have a acceleration. So when we go at 0.1 after 0.1 second, there will be a acceleration which is acting opposite to the velocity of the ball. So what will happen is that the velocity will change like this. So we'll say velocity which was at time 0 plus or minus gravitational force into dt. So how did I come up with this? So again we have a velocity, and this velocity will change according to the acceleration. So you can see that there are 2 seconds in the denominator for g So if you multiply with the dt, then we get a unit of velocity. So we are subtracting that velocity from the velocity in the y direction. However, the velocity in the x direction would remain same. So we can drag these numbers down and see that the velocity in y direction is changing, but velocity in x direction is same. And then we can calculate the distance. So at the very beginning, the x will be 0 and y will also be 0, and then it will change. So the position in x direction will change according to the time. So we'll say that velocity into dt, and same way for the y, so velocity into dt. So now we can drag it down and see that the position I forgot to do one more thing. So here the x, so this is the amount or the distance which the ball has moved in the x direction, but we should add the position which was there at the initial step. So I have to say x plus the amount or the distance it has traveled in time dt. So same way here we have to add the initial position. So now if we drag it, you can see that the position will change. So this is how it will go, and we can keep dragging it for a long time. And now I can plot x versus y to look at the trajectory of the ball. So if I plot this line x versus y and say so this is what is the trajectory of the ball. And if I want to assume that I'm not standing on a mountain but I'm standing on a plain ground, so I can just end the simulation when the ball touches the ground. So for that I can just format the axis and set the minimum to be 0 and maximum, suppose let's do it. I have to see how much what is the range of the simulation, but let's do 500 here. And same way for the y, let's fix it to 2500. And now you can see that this is the trajectory of the ball. So now I can change these numbers and look at how the ball will move in x or in the air. So let's say that velocity, the angle, I change it to 45 degrees. So you can see, so now you can see that the simulation is not complete, so I should simulate it more. So here I will increase the range to suppose 1000 points. Yeah, select data, edit, and say 6 and 6. So now we can look at this again. So as you can see, when I have 45 degrees, then it goes to around 1000 or 1039, and if I change it to 55, then instead of going to 1059, it goes to 982. So as you remember, when you learn the trajectory of a ball, the ball goes to the maximum distance when the angle you throw at is 45 degree. So now you can see that when I was throwing at 45 degree, it was going to 1050, but when I throw at 55, it goes to around 950. And again, if I throw at 35, then again it goes to around 975. So the maximum distance you will cover will be when you throw it at 45. So this confirms that our simulations are correct. So now you can play around with it, saying instead of 35, if I throw it at 20 degrees, then it goes pretty much up, and if I throw it um, at 80 degrees, then it doesn't go up but mostly towards the ground. It doesn't take a lot of height. So I hope this tutorial will help, and I'll see you next time.